Hello, everybody. Today is day 27 of Coding Every Day. Today is a Tuesday, February 11th at 3:03 p.m. So last time I designed Twitter. I did this problem using a heap. It took me 2 hours, but eventually I got the recommended time complexity. Normally I don't spend that long on a problem, but I thought it was pretty close, so I stuck with it. I also did, I finished all the medium backtracking problems. So today, according to this chart, there is a couple different ways I could go. I could do tries, intervals, greedy, advanced graphs, graphs. Actually, I can't do advanced graphs. Or one dimensional dynamic programming. So yesterday in my free time, I did climbing stairs, which for those of you who don't know, it's basically just a Fibonacci sequence, and I was still kind of working through it. I didn't really feel that like I had a total mastery over what was going on. So for now, I think I'm going to wait on dynamic programming. So I'm going to jump into the first graph problem here. Number of islands. So I haven't read it on this website yet, but I think this is a pretty famous graph problem. So you get a 2D grid of ones and zeros. 1 is land and 0 is water, and you have to return the number of islands. Yeah. So basically, for instance, there's only one island. It's this island right here with this contour or shape. And here there's 4 islands. So here's 1 island, 2 island, 3 island, 4 island right here. Okay. So my idea to this, let's say we have our grid here. So my idea would be you check every position until you find land. Once you find land, you basically just traverse everything in the land and mark everything as visited. So let's say like this. Let's say this is your island, right? So you find all of those and mark everything as visited. So remember, we checked here, and then we checked here, and that's when we did that. So the next spot we're going to do is here. But because it's in visited, that means we just skip over it. And then we check here, and let's say it's, we get all these zeros, so we don't do anything. And then if we find a 1, let's say here, that we haven't explored yet, then we increment the number of islands by 1. So whenever you find a 1 that you haven't explored yet, that is a new island. And I think you can just do this until you get until the end. And then you just have your number of islands. So the time complexity of that, well, obviously you have to, I think it would just be like the size of the matrix. Yeah, m times n and m times n space, because we need a visited. So that this solution that I just described would be m times n time n space. So what we want to do is like, so I guess we could call scan every point. If point is unexplored 1, then explore island and increase num islands by 1. I could just say num islands plus equals 1. Right, so we're going to scan every point. If it's an unexplored 1, then we explore the island. So in terms of how I want to set this up with code, I guess we could start with scanning every point. So I can make a function called explore island. Which takes in a position. I'll say row and column, and it's going to return nothing. Can I just do that here, or does that not work? I don't know. So it's going to return nothing. And then in here, in our main function, or I guess like down here, we want to say for row in range length of grid. So that's the number of rows. And then for column in range length of row. We want to, so if grid of row column is so equals 0, then we will continue. If row column in visited, then we will also continue. So if it's a 0, we go to the next one. If it's in visited, we go to the next one. Otherwise, we want to explore island with row and column and say num islands plus equals 1. And then here is where we will add to visited. So visited needs to be a set of coordinates. So we'll just make it an empty set. And then here we will add to the set. So if explore island is just going, let's say our function just prints row and column for now. Then this should, and then if let's say we return 0, so this should print out every row and column. Okay, so this should be, I was going to do it like that, but I decided not to because row is an integer. Num islands doesn't exist. So I'm just kind of getting the skeleton going. So 0, 1, 0, 2, 0, 3, 1, 1, 1, 3, 2, 0, 2, 1. Okay, this doesn't seem right. Oh, because it's not the zeros. Okay. So 0, 1, 0, 2, 0, 3, 1, 1, 1, 3, 2, 0, 2, 1. Okay, so that's working. So it's exploring all of the non-zero elements right now. It's just printing them. Okay. I also want to make a function called, actually I think I can do that here. Okay, so we could just do a depth first search. So we'll have our stack equal to our row and column. Okay, we'll say while stack current equals stack.pop. So I'll call this row and column. Row and column, and then here I'll call it R and C. So this will be the current positions. Okay, so we're going to pop from the stack, and then we'll say okay, so now I'm going to explore all 4 of the cardinal directions. So up, so we'll start with left. So left is the same row and minus 1. So we're going to have 4 tuples here. So the same row and then minus 1, because minus 1 column. Up is minus 1 row and don't change the column. Right is same row and plus 1 column. And down is plus 1 row and minus 1 column. Okay, so now here we want to check if it's in bounds and if it's a 1. All right. So if grid of row column is 0, then we'll continue. And if, I guess we can say, or if grid of RC is invisited, then we will continue. So basically don't do anything. Otherwise, we want to say stack.append row, so a tuple, row plus delta row and column plus delta column, like that. So for instance, it'll take the current position and then add these like that. And then we want to say that we've visited, after we're done exploring that, we want to say visited dot add row column. So the tuple row column like this. And we don't want the grid point, we want if or row columns and visited, because visited is a list of tuples. Okay. So let me see what number of islands is. I don't know if that'll work. I'm expecting I have some bugs. All right, let me just return it, I guess. Return them islands. Okay. So I forgot to check if it's not bounded. So I tried to do this in another video, but I forgot how. So I think it's if 0, I'm going to do this up here. So basically this will check if it's bounded, and I'm doing an anonymous function with the keyword here. So if 0, if the row is less than 0, or I guess greater than equal to 0, or length of, it's less than the length of the grid, and column is same thing, except less than grid of 0, because it's a square grid, right? Or, yeah, I don't think each one can be of different height, is what I'm trying to say. It has to be a rectangle. Okay. So if I say that equals that function, oh, I think I can just pass it, right? So if I said xy, and let's say xy, and then I pass RC like this, I say R equals, let's say 4, and C equals 5. Alright, I'm going to try putting some parentheses here and see if that does anything. Okay, that actually did do something. So it's saying false, it's not bounded. Is that correct? So that looks correct. What if I put 0, 2? True. Okay. Could I also just pass? If I say like x. So now I'm trying to just see if I can pass in the variables like that. No. So you have to call it. Okay, so I have to do it right here. So if zero less than or equal to x length of grid, and 0 less than or equal to y less than so if it's not bounded, then we'll continue. Oh, I have to add plus C. So basically I was just appending this, but we want to do it for all the directions. So yeah, so let's say new r equals r plus delta r, and new c equals c plus delta c, just so I don't have to type it so much. So new r and then new c, and new r, new c, and we'll just say here new r, new c, and here new r, new c, like that. Okay, let's see. All right, I think it's probably this part, to be honest. So I'll just make a function called bounded. Also, I'm working in the smallest window ever. Okay, so which will take a row and a column. So return if 0 is less than or equal to row, which is less than length of grid, and 0 is less than or equal to column, which is less than length of grid. Okay, so it looked like my lambda function wasn't working. I saw some guy do it, and it, like, the way I'm doing it looks absolutely horrible. So I don't know what I'm doing wrong. But either way, so that's that problem. It's pretty straightforward. You basically just do a DFS on every island. And like I said at the beginning, if you come across an unexplored one, then you know that it is a new island. So I just put num islands plus equals 1 there. Yeah, so that's this one. I guess I could add some comments. Bounded is pretty self-explanatory. Explore island. It's also pretty self-explanatory. It's just a depth first search. Discard water, zeros, and already visited islands. And I'll just combine this here. That's the wrong answer. Typo. All right. Then for every I guess I could say every unexplored island. I guess every unexplored one is a new island. Okay. Perfect. Okay, great. This reminds me a lot of the Advent of Code problems I did in the early videos of this channel. I'm glad I'm getting more confident, which is, depth first search. And yeah, thank you guys for watching. Today was day 27. We're getting very close to a month, which is awesome. Feeling good. So thanks so much for watching.